Hello class, in this lesson I'm going to explain to you this particular problem. Solve the following system of equations by the indicated method. This one, the graphical method. I have already explained to you this one, the substitution method. Okay, in the previous lesson, I made the post in your team and you should have watched that lesson already. And now let's go on to the graphical method, and then I'm going to give you another lesson which I already have prepared from the previous semester, in which I explained to you the addition or subtraction method, also known as the elimination method. But let's first address this one, the graphical method. What is this about? Okay, let me bring my pencil. Okay, technically speaking, in order to solve a system of equations such as this, we have remember why is it called system of equations? Because you have two equations, so they work as a system. You see, as a single unit, so to speak. They are interrelated. That's what I mean. And basically, what you have to do is, in this case, you have to plot each of these equations in the Cartesian plane. What does that mean, to plot or to graph an equation? Well, each of these equations, when you have an equation, a linear equation in two variables, such as this can be represented in the Cartesian plane by following a very simple idea, which is the following. I'm going to explain to you very briefly what you're supposed to do by hand, but technically we're not going to do this by hand. I'm gonna use a software that is on internet in order to solve this particular problem. But if you didn't have software, if you wanted to solve this by the graphical method, what you have to do is this. You have to graph first this equation, and the graph will result in a line. That's why that's why these are called linear equations, because when you graph this, it results in a line. And how do you graph this thing? Very simply, you do the following. You're gonna isolate the y variable from this equation. I'm gonna do it in here. You see, this is the isolation of the y variable in this case. And if I do the same for the other, I will be getting that y equals minus 3x minus 15 over 3. Check it out on your own, please. Okay, and then what you have to do with these two equations is the following. Independently and separately, like first let's begin with this one. I'm going to graph this equation, which is the same as this, right? They are the same equation. How do you do that? You're going to construct a table of values this way. You're going to assign some values to the x variable, any values you want. For example, some simple ones, minus 2, minus 1, 0, 1, and 2. It's always a good idea to give integers, and I could continue, in fact. And then I'm going to get the corresponding value of y for minus 2 according to this equation. So if you gave x minus 2 in here, then you're going to get minus 2 minus 3, you're going to get minus 5. And then if you gave x the value of minus 1 right there, you're going to get minus 1, minus 3, minus 4. And you kept doing the same, you're going to be, I'm sorry about that. This is going to be minus 3, minus 2, minus 1, etc. So now with each of these pairs of values which correspond to each other, you're going to create a point. You're going to understand this as a point, minus 2 comma minus 5, that you can plot in a Cartesian plane. Minus 2 comma minus 5 is this point, then minus 1 comma minus 4 is this point, and you keep doing the same for those points like this, and then you trace the line crossing or passing through those points. Okay, and we say that this graph, this line, represents this equation, which is the same, as you remember, as this one. They are the same equation, and this is the visual representation of such an equation. And you're gonna do the same for the other, which I'm not gonna do. what I'm gonna do instead is the following. I'm gonna take both equations and then I'm gonna graph them quickly on a software graph calculator as follows. We have x minus y equals 3. So let's put it in here. X minus y equals 3. And as you can see, this is the graph. Just as I can you see the same? Can you see? It's the same graph. Can you see? It crosses both axes at -3 and 3. And let's see if that happened in this graph. As you can see, this is -3 and this is 3. So it's the same line. In the other, 3x plus 3y equals -15. There you go. Okay, so I was gonna do this by hand, but it's the same whether I do it on a software calculator or by hand. Basically makes no difference. And basically, what the next thing you have to do, guys, is take a look at the intersection between those two lines, which is this point. That point, that point at which they intersect each other, this is the solution. This is the solution. This point, -1 comma -4, that is the solution to this system of equation. What does that mean? That this is the solution to this system of equations. Okay, if you replace, let's take for example this one first. If you replace the x for -1, let me do it, and then the y for -4, be aware that you have a minus in there, minus, and then y, and y is -4 according to this point. Are you gonna get 3? The answer is yes. -1 plus 4 is 3. So as you can see, this equation is satisfied by this point. You see, being the first coordinate x and the second coordinate y. And the same is going to happen to the other equation. If you introduce in the place of x, if you introduce the number -1, and in the place of y, you introduce the number -4, this equation will also be satisfied. What that means is that this point, or this pair of numbers, -1 comma -4, the first one representing x, the second one representing y, is the solution to this system of equations, because these satisfy both equations at the same time. At the same time. That's what it means. And that's basically how you solve a system of equations by the graphical method. Basically, you're going to graph them, and you're going to take a look at the point of intersection, and that is the solution for this system of equations. And that's it. That's how you can solve. Well, I already solved it for you. You just basically have to copy the whole thing, copy the graphs in here, these two graphs, and then basically highlight the point of intersection. That's how it works.